Muscle endurance plays a crucial role in endurance sports like distance cycling and running, swimming, or cross-country skiing. But muscle endurance is also important for other sports, such as basketball, rugby, soccer, and volleyball. Needless to say that you can enhance your muscle endurance by regularly performing endurance training. But did you know that type 1 muscle fibers are important for muscle endurance? And that endurance training exerts its effect via mitochondria with a key role for PGC1 alpha? No? Stay tuned. I will explain this in the next few minutes. Muscle endurance is the ability of skeletal muscle to perform submaximal work over a long period of time. To better understand muscle endurance, we have to have a closer look at how skeletal muscles are built. Skeletal muscles are made up of many parallel muscle fibers. Muscle fibers can be roughly divided into two types, type 1 or slow twitch fibers and type 2 or fast twitch fibers. Our muscles do always have a combination of fiber types, so they are mixed, although the proportion differs from muscle to muscle and between individuals. So you do have muscles with a lot of type 1 fibers and muscle with relatively more type 2 fibers. And you have people born with a lot of type 1 fibers, whilst others do have relatively more type 2 fibers. Let's have a closer look at the fiber types. Type 1 muscle fibers contract slowly and do not generate much force. They are able to be used for a long period of time, so they are resistant to fatigue. Type 1 muscle fibers do have a lot of capillaries, the smallest blood vessels in the human body, to supply oxygen. And they contain a lot of mitochondria. I will come back to this. Due to a good oxygen transport capacity of these fibers, they appear red, and type 1 muscle fibers are also called red fibers. Type 1 fibers do contain a limited amount of glycogen, but lots of fat, so-called intramuscular triglycerides. All these features mean that the type 1 muscle fibers are very good at producing energy via the aerobic or oxidative pathway. It will not surprise you that type 1 skeletal muscle fibers are excellent for performing endurance exercise. And elite endurance athletes have a large proportion of type 1 fibers in their muscles. Type 2 fibers are fast and white. Type 2 fibers can be divided in type 2A and type 2B. I will come back to this in a minute. Type 2 fibers can generate a lot of force, contract quickly, but also fatigue easily. They contain fewer blood vessels and mitochondria, but high levels of phosphocreatine and glycogen. They are better equipped for anaerobic metabolism and high power output performance. Good sprinting athletes have a large fraction of type 2 fibers in their muscle. As I said before, type 2 fibers come into two subtypes. Type 2B fibers are the typical fast and easy fatigable fibers, while type 2A fibers are more intermediate in their characteristics, so between type 1 and type 2B fibers. They have a fairly good oxidative capacity, a bit like type 1 fibers, although they are still fast twitch fibers that can generate a lot of force and fatigue more easily, as you can see in this table. But now back to muscle endurance. At the basis of the good oxidative capacity of type 1 fibers are so-called mitochondria. A mitochondrion, you can see one on this picture, is a small structure in the cell where oxidative metabolism takes place. Oxygen is utilized in mitochondria to create energy, as they are well equipped with all enzymes involved in the aerobic metabolism. That's why mitochondria are considered the powerhouse of cells. Anaerobic metabolism, so glycolysis and phosphocreatine breakdown, doesn't require mitochondria. Endurance exercise training increases the number and improves the function of mitochondria. Two key signals that regulate the number and function of mitochondria are 1. The calcium released during contraction, and 2. The decrease in energy in the muscle cell during exercise. Both signals will finally activate a protein called PGC1 alpha This PGC1 alpha is considered to be the master regulator of mitochondrial adaptations due to endurance training. This brings me to the end of this video. You have learned that muscle endurance, so the capacity of the muscle to perform submaximal work over a long period, is mainly dependent on type 1 muscle fibers. Type 1 muscle fibers are highly oxidative and have a good blood supply and contain many mitochondria, while type 2 fibers are more for power sports. Endurance exercise training regulates the number and function of these mitochondria via PGC1 alpha. Elite endurance athletes have a good muscle endurance, but more is needed to make you an elite marathon runner.